Alright, this video begins our Chapter 2 study of rational numbers. In this video we'll look at how we compare and order rational numbers. So, first of all, definition of a rational number. A little bit of a complicated definition maybe, but we'll try to explain it. And rational number is defined as a number that can be expressed as a divided by b, where a and b are integers and b does not equal 0. Okay, so what that means is integers, remember, are any numbers, either positive or negative numbers, that are whole numbers that don't have decimals with them. And b does not equal 0, and that's simply because, remember, we can't have a fraction that has a denominator of 0. So b cannot equal 0, and both a and b need to be a whole number, basically, or an integer. It could be positive or negative. So examples would be numbers like -4. Well, how does this work as one? Well, we could write -4 as equivalent to -4 divided by 1. Okay? Both a and b in this case, but the top number and the bottom number are integers, and b, the bottom number, does not equal 0. Another number that we could write as this could be a -1/2. This would be a rational number. Okay, same thing. Or a 0 could be a rational number, right? Any of these would be examples of rational numbers. Another way that we can define rational numbers is any number that can be written as a fraction that is either a terminating decimal, meaning if you punched it into the calculator you could see that the decimal would end and wouldn't go on forever, or a repeating one. Okay, so if the number repeats over and over again, that also qualifies as a rational number. Okay, so how can we compare then? If we're given a list of rational numbers, how would we be able to compare to see which ones are bigger, so that we could write them in either ascending order, so ascending means getting bigger, or descending order. Okay, so one method would be to use a number line. So remember, number lines, we would draw it out, we'd have 0 somewhere in the middle, and we'd be asked to place different numbers on a number line. Okay, so perhaps we are given these numbers to compare. We're given 1/2, -4/3, 0, and 4. Okay, and we're asked to compare. So we could place each of these on the number line and then determine which one is larger by looking at where it is located on the number line. So further to the right means larger. If it's further to the left, it is smaller. So let's do that for this example. 1/2, we know, appears between 1 and 2, somewhere right there. Okay, so that would be where 1/2 appears. Okay. -4/3, well, negative means we are on the left side of 0. -4/3 is bigger than -1, but not as big as -2, or sorry, I guess not as small as -2. It's somewhere in between -1 and -2. It's going to be somewhere in there. Okay, 0, of course, we know where 0 is on the number line. We've already labeled that. Okay, and then finally, we've got number 4 would be 1, 2, 3, 4, right about there. Okay, so we can see that if we wanted to write these in ascending order, that means we start with the smallest number. Smallest is the one closest to the left, so that's -4/3. Then the next one is 0. The next one is 1/2. And finally we have 4. So that would be one method of ordering number lines. Okay, then we can look at another method. Okay, this method is using equivalent fractions. So if we're given different fractions, so say we are asked to compare negative 3/4 with a negative 2/3, which is bigger? Well, you might start confusing yourself if you think about that, right? Because the top numbers, maybe you think that 3 is bigger, but then with negatives, maybe that changes it. Well, an easy way to look at it is by writing each of these fractions as an equivalent fraction so that the denominators are common. So let's look at the denominators here, 4 and 3. What would be a common denominator between them? Well, 12. 12 would be a common denominator between them. So can we write negative 3/4 as a fraction, an equivalent fraction to negative 3/4 that has a denominator of 12? Well, sure. We can write it as negative 9/12. Okay, and remember how we get that? We look at what it takes to get the one denominator into the other. So to get from 4 to 12, we needed to multiply by 3. Okay, we need to do that same thing on the top, multiply by 3. Negative 3 times 3 is negative 9. Okay, over here we're going to write this negative 2/3 as something over 12. Okay, so this 3, it took us multiplying by 4 to get that, which means we have to multiply the top by 4. Negative 2 times 4 is negative 8. Okay, we now have two fractions that have common denominators that we can simply look at. So negative 9/12 and negative 8/12, which of those is bigger? Well, remember on a number line, okay, we say that bigger is to the right, big is over here, and small is over here. The number negative 9/12, well, 9 is a bigger number than 8. Negative 9 means that it's actually going to be further to the left than negative 8, which means that negative 8/12 is actually going to be the bigger number because it is further to the right on the number line. Okay? So that would be another method to use. That's using equivalent fractions to put them in common denominators and then be able to compare that way. One last method we'll look at is by using decimals. Okay, so if there are, we'll use two other ones we'll compare. We'll go 2/3 and 6/8. Okay, comparing those, we could convert each of those into decimals. 2/3 we know is 0.66 repeating. 6/8 is 0.75. Convert it, you can now see, you can compare easily. Ascending order would be the 0.66 is smaller than the 0.75, therefore the fractions must be 2/3 is smaller than 6/8. Okay, that's comma, not a greater than sign. Okay, so those are three different methods you can use to compare and order rational numbers. We'll do some practice problems together in class tomorrow, and hopefully you'll get the hang of this. Okay, thanks. Hope that was helpful.